Hello everyone, my name is Diksha and I am from the Bodhi Academy. Since I am taking some topics from 12th standard chemistry, today I will start with the electrochemistry chapter. Okay, we will cover some basic things from this electrochemistry chapter, and along with that we will solve some problems, important problems from this chapter. Let us start with the basic. So what is electrochemistry? Okay, now first we will try to understand the meaning of electrochemistry. Electrochemistry. Okay, now from name itself we understand that this is related to electricity and chemistry. When electricity is combined with the chemical reactions, what happens to that? So in electrochemistry basically we have two types of reactions, that is, one is electrochemical and other is electrolytic. Okay, so first we will see about electrochemical reaction or electrochemical series. So electrochemical reaction, what happens here? We are converting chemical energy to electrical energy. Okay, meaning we are carrying out a reaction in which chemical reaction is used to convert that energy into an electrical energy. Okay, and this is a spontaneous reaction. This is a spontaneous reaction because chemical reaction takes place spontaneously to give the electrical energy. Okay, so this is a spontaneous reaction in electrochemical reaction. Next we will say about electrolytic cell or electrolytic reaction. Okay, electrolytic means what? Here the opposite happens, that is electrical energy is converted to chemical energy. Okay, now since this chemical reaction couldn't take place on its own, that is spontaneously, we have to apply some external energy over here. That's here we are applying electrical energy to converting them to electrical energy. So this is a non-spontaneous reaction. Okay, so this is a type of non-spontaneous reaction. Okay, this is about the basic introduction of electrochemical series and electrolytic reaction. Under electrochemical, we have an important example here, that is a Daniell cell. Okay, so in last year also in 11th standard we had learned about the Daniell cell, what takes place here. So I will just explain briefly what happens here in the Daniell cell. Okay, so it is a setup of two half cells. So we have two containers like this. Okay, so one is having both containers are having electrodes. So both are having electrodes, but here we have zinc electrodes and here we have copper electrode, and in this we have copper sulfate solution and in this we have zinc sulfate solution. Okay, then these two electrodes are connected to each other, okay, through a battery, and here bulb is connected. Okay, now this is a rough diagram just to understand, just to make you understand. Okay, now zinc electrode is called as anode and copper electrode is called as cathode. Okay, then next is, this is zinc sulfate, this is copper sulfate. Now these two electrodes, they are dipped in the electrolytic solution. So this is the zinc sulfate and this is the copper sulfate. Both the electrodes are dipped. Okay, then next thing we have is a salt bridge. Salt bridge here, okay, which connects both the half cells, and in the salt bridge there is a salt called as KCl. Okay, now I will explain the Daniell cell, what happens here, how the chemical energy is converted to electrical energy. So when I put zinc and copper in the respective solutions, what happens? Here zinc, since it is more reactive than this copper, what happens? Zinc will try to give the electron. Zinc is rich in electrons. Okay, so what happens? Zinc will give the electrons. So zinc rod, which is a stable metal, it will try to give the electrons. So how zinc have tendency to give 2 electrons? So I will write here, zinc gives zinc 2 plus 2 electrons. After losing 2 electrons, it will form zinc 2 plus. So half reaction of this cell is zinc gives zinc 2 plus 2 electrons, and those electrons which are given by zinc will be accepted by copper. Okay, so here copper will accept. Copper 2 plus 2 electrons gives copper. Okay, so here the electrons which were given by zinc will be accepted here in the cathode, that is copper rod, and those electrons are accepted here. Now in copper sulfate, when you have a copper sulfate ionic solution, what happens when you put any salt in the solution or in a solvent? We get both the ions separate. Dissociation of ions takes place. So if I put copper sulfate, I will get copper 2 plus SO4 2 minus. Okay, so here in this solution there is a dissociation of copper 2 plus SO4 2 minus. So copper 2 plus, what will happen when the 2 electrons are taken by copper from zinc? This copper 2 plus will gain those 2 electrons and will deposit more and more copper on this rod, and zinc electrode will be depleted. Okay, here the size of zinc electrode will be, now it is decreasing. It is not the way it was before, but here the size of the copper electrode, that is a cathode, will increase. Okay, so here more and more copper will deposit. Okay, so here we are giving electrons which are taken by copper 2 plus ion from the solution, and it is depositing on the rod. Now what happens here? Zinc is giving electrons. Okay, so we are having Zn plus 2. So in this water, after giving 2 electrons in this solution, we will have more of these electrons, 2 electrons which are released, 2 electrons which are given, and zinc 2 plus ions. Okay, so in this solution we will have zinc 2 plus ions. More and more zinc 2 plus ions will be generated. Similarly, here copper will accept the 2 electrons and will form copper. No, so here SO4 2 minus ions will be generated. So here more and more SO4 2 minus ions will be generated, and here zinc 2 plus ions will be generated. So here we will have more of positive charge, and in this we have more of negative charge. Now what happens? To balance this or to continue the reaction, we have to put something in the cells so that it will neutralize the cell, the whole reaction. So what we have to do? Here we have to put a salt bridge in which there is a salt, which is KCl. So when we put salt, we have in salt we have one is positive, one is negative ion, so K plus and Cl minus ion. So this K plus will combine with SO4 and will stabilize the whole reaction. Same way chlorine will combine with this and it will try to stabilize the whole reaction. So that's how the reaction continues. Okay, so this completes the cell circuit. Okay, so that's why we get the continuation of reaction takes place and the bulb starts glowing. Okay, so here what you have to remember, how the Daniell cell works and what are the two half reactions on each electrode. Okay, that are taking place. So here we have, this is a most important thing in the Daniell cell. Then we have a very important equation from this chapter, that is a Nernst equation. Okay, before that we will study the Nernst equation, and in Nernst equation we use E naught of cell. So Nernst equation formula is E of cell is equal to E naught of cell minus 0.059 by n log of product concentration upon reactant. Okay, so first we will see what is this E naught of cell. Okay, E naught of cell is the reduction potential of the cell. Okay, so if to find the E naught of cell, values will be given. Now if I have Daniell cell, then E naught of zinc plus to zinc, E naught is minus 0.76, and of copper is Cu2 plus Cu, which is 0.34. Okay, now here in this cell, which is cathode and which is anode? Cathode is our copper and anode is zinc. So the formula goes like this: E naught of cell is equal to E of cathode or E naught of cathode minus E of anode. Okay, now our cathode is copper and E naught value is 0.34 minus this is 0.76. So this will come up to 1.1 volt. So E naught of Daniell cell is 1.1 volt. Now if I want to substitute this in the Nernst equation, the formula is E of cell, that is EMF of cell, is equal to E naught of cell minus 0.059 by N log of product concentration upon reactant concentration. Okay, so now E naught of cell we got 0.059 is the answer that we get after multiplying every constant, and N, now N is what? It is the number of ions being exchanged. So in this reaction, if I try to write the overall reaction from this two reaction, the overall reaction will be this way. So we are giving 2 electrons from zinc, so it will be zinc plus, to whom we are giving? We are giving to copper. So zinc plus copper 2 plus will give zinc 2 plus plus copper. Okay, so from this reaction what you understand? Zinc, the metal, in stable form, it will give, since it is electron rich, it will give 2 electrons. To whom? To copper 2 plus. So copper 2 plus will accept the electrons and will form copper, and zinc will lose electrons and will form zinc 2 plus. So here in product side we have zinc 2 plus and in reactant side we have copper 2 plus. So for Daniell cell, the values are E naught of cell is 1.1 minus 0.059 by N. N value is 2 because 2 ions are being exchanged. Then log of, now here concentrations I have not mentioned, so we will take random concentrations here. Suppose copper 2 plus we have 0.01 molar and zinc 2 plus we have 0.1 molar. Okay, these concentrations will be given which you have to put here. So product is what? Product is zinc 2 plus. Okay, here we have to only write ionic products. You cannot write the stable product. Okay, so product is zinc 2 plus. So here I can write zinc 2 plus and upon copper 2 plus. Okay, then 1.1 minus 0.059 by 2 log of 0.1 by 0.01. Okay, because zinc concentration is this and copper concentration is this. So I will get 1.1 minus, the answer of this after calculating you will get 0.0295 log of 0.1. Now 0.01 is what? 0.01 can be also written as 10 raised to minus 2. Okay, so now what we can do here? 1.1 minus 0.0295 log of 0.1 into 10 raised to 2, because after taking this term here in the numerator, the negative sign will change to positive sign. So we will get 1.1 minus 0.0295 log of, now 10 raised to 2 means 2 values will shift, so we will get log of 10. So 1.1 minus 0.0295 log of 10 is 1. So into 1 I can write. Now here you have to remember one thing, that first you have to carry out all the calculations which you have after negative sign. Okay, don't first subtract the numbers with this. So after getting a proper answer after your negative sign, you have to subtract that particular value. So here I will get 1.1 minus 0.0295. So you can subtract this 1.100 minus 0.0295. So here I will get 5, then 0. Okay, so I will get answer as 1.0705 volt. So this is the EMF of Daniell cell. So this is the answer for EMF of Daniell cell if the particular concentrations are given. Okay, so this way you have to solve the problems on this EMF of cell. Okay. Next problem they can ask on the Gibbs energy, that is Gibbs energy, or how the Gibbs energy equation and equilibrium constant of the cell. Okay, so here what we can do, we can take a example over here. So if they have given a particular reaction, that is Mg plus 2 Cu plus 2. Okay, so here this is a representation of cell. Okay, this is basically a representation of cell. Magnesium plus 2, copper plus 2, copper. So from this reaction, how we can write? We can write the reaction as Mg plus Cu plus 2 gives Mg plus 2 plus copper. Okay, so in this cell representation we can see that the left part which is shown is of anode and right one is cathode, and the middle one, the lines, two lines, they indicates the salt bridge. Okay, so we got to know the particular reactants and products. Okay, so this is a way to write the reaction over here. Then if they are the formula for equilibrium constant and Gibbs energy. So equilibrium constant formula is given by E naught of cell is equal to 0.059 divided by n log Kc. So Kc is the equilibrium constant over here. Okay. Now here how we can find the value for this. So E naught of cell will be already given. Okay. So if they have given the E naught of cell, you can put the particular value of E naught of cell. N value is what? Here how many ions are being exchanged? 2 ions. So N value will be 2. So you can write 0.059 by 2 log Kc, and particular E naught cell value you have to put. Okay, so then we can get the E naught of cell on the other side, and we can write log Kc is equal to E naught of cell into 2 divided by 0.059. So this will give us the answer for log Kc. Okay, and after getting the answer for log Kc, we have to put the log on the other side, making it anti-log, and then we'll get the final answer. Okay, so this is the way to find the equilibrium constant for the reaction. And next formula is the Gibbs energy constant. So that is delta G naught. Okay, so how to find this? Here we have to use the formula delta G naught is equal to NF E naught of cell. This is very simple, minus NF E naught of cell. N is the electrons which are being transferred. Suppose there are 2 ions or electrons, then F is the 1 Faraday, that the value is 96500 into E naught of cell, which will be given, or we have to calculate from the formula. Okay, so this is the formula for delta G naught of cell, which is a Gibbs energy. Okay, so these three are the important formulas from this chapter. Okay, so rest problems we will discuss in the next part. Okay, so yeah, thank you for watching the video, and we will continue in the next part.